This is video number 7 on Proteus circuit simulation for first year engineering students. In this video, you're going to learn how to use voltage and the current probe. So I'll be covering the following things in this video. So I'll be covering the basics of the current and the voltage probes. You already know how to use the voltmeter and the ammeter. So to put in simple words, a voltage probe is an alternative to the voltmeter, and the current probe is an alternative to the ammeter. So this is just a simple definition. So you can do more using voltage and current probe than you can do with the voltmeter and ammeter. Some of the advantages are, if you're already using voltmeter and ammeter, you know the voltmeter and ammeter, they occupy more space in your circuit schematic diagram. So whereas these two probes, they take less space on a circuit diagram. One more advantage is you don't have to break the wire before you insert a voltmeter or ammeter. So assume that you already have a circuit in Proteus and you would like to use a voltmeter or ammeter into this circuit. So what you'll end up doing is you will first have to break this and introduce the ammeter, and as well as if you want to introduce the ammeter here, you have to break this and put the ammeter into the circuit. So whereas breaking of a circuit is not required for a voltmeter, so however, just have to keep in mind that it takes less space, and you can easily add or remove the current and voltage probe from the existing circuit. The knowledge of using the the current and the voltage probe will be helpful to you in circuit analysis. Say for example, if you're doing the nodal, or if you're trying to find the nodal voltage in nodal analysis, or if you're working with the Norton or a Thevenin circuit, so the knowledge of this current and voltage probe will be. So I've taken a simple circuit with the battery and 3 resistors R1, R2 and R3. Now assume that you have been asked to find the current passing through resistor R1 and the current passing through resistor R3 and R2, and also you have been asked to find the voltage difference, or the voltage at this point, the voltage at this point. Now you know how to do this using the voltmeter and ammeter. So you know that to introduce the ammeter, you have to break this wire and bring the ammeter, and if you want to introduce ammeter in this R3 branch or the R2 branch, you have to break up this wire and introduce the ammeter. So introducing your voltmeter may not be difficult, you just have to connect that in parallel. Now I have got a circuit. So I have done this already for you. Now this is how you might end up doing if you want. Now this is exactly the same circuit. I'm going to zoom this a little bit. Yeah, you can see here what I've done is taken this the circuit on the left hand side, and I've introduced the ammeters and voltmeter wherever I want to get the reading. So you got ammeter here, so you'll know what is the current flowing through resistor R1, and the ammeter I got here so that you know what's the current flowing through this resistor. So because these two circuits are in the same worksheet, you cannot have the same name. So here it's R3, where here it's R4, but the value of the resistors are the same. So I also introduced the voltmeter across this resistor so that you know what's the potential difference between the ends of the resistor. I've done the same thing for this branch also. Now if I run the simulation, so you can see the current is 1.13 amps, and the voltage across this resistor, the 3 ohm resistor, is 3.39, and you can also verify that these answers are, it has to be accurate. So you know that the current 1.13 amps, which is in this branch, gets split into the two parallel branches here. So when you add up the current in this branch 0.81 and the current in this branch, these two should add up to 1.13. So this is what the Kirchhoff current law says. So you know the Kirchhoff current law, the current into the node must be the same as the current out of the node. So in other words, the definition is the algebraic sum of the current across at any node must be is equal to 0. So this is just a definition you have to remember. Now I also got exactly a similar circuit, but this time, so I have used the current and the voltage probe. There is a little trick in some scenarios on how you use the current and voltage source that I'm going to show later. If you compare the values of the current in here and here, you can see that the current in this through resistor, the 3 ohm resistor, is 1.129, which is same as 1.13. There is a bit of a rounding error. If you see the voltage across this resistor R4, which is also same as the voltage at this point, you can see here this is 1.61. So we got here 1.61. So the voltage here, you can see the voltage probe is this one, the left hand side, and this is also, I got one more voltage probe here, and this is a current probe. Now the difference between the way you differentiate these two is the current probe, there's a direction. You can see here there is a direction, there's an arrow next to this there's a direction. I would say there's a direction next to this arrow. So this is a voltage probe and this is a current probe, and you can see the current through this branch is 0.8. If you round this up, you'll end up getting 0. You can see these two current will be the same, and also the current what you see that is measured by this current probe is 0.32, which is same as the 0.32 amps here, and the voltage 1.61 what you see here. So this is the voltage at this point, okay, which is read by this voltage probe 1.61. Now the only drawback what I have seen in this current and voltage probes are sometimes it's not very easy to see the readings. As you can see here, there is a accurate current reading here, which is vertical upwards. So I'm going to zoom this little bit, so you can see here. You can see here the current reading for this the current probe. For this current probe, the reading is you can see it's the equal sign here, followed by this number 0.8061. I somehow did not get to move this reading away from where it is now. So if you know how to do that, please put a comment so that it is going to be helpful to other students. Next, I'm going to show you how to place this voltage and the current source, and also there are few points you have to keep in mind. So I would also advise you to see the help. So most of the time we just go and follow all the videos, but there is a nice explanation about this software. I found the explanation about the simulation is very helpful. So if you get a time, just go through that. So seeing the videos and reading this help text will be very helpful to you. I'm going to keep this working diagram as it is, and since this is a demo version, you cannot save these diagrams. Now what I'm going to do is I'm going to select this as a block, and sorry, I have to stop the simulation. I'm going to move this little bit in the corner. So I'm going to do the same thing. Just drag your mouse covering this entire circuit diagram, and you can move here. And also going to do the same thing here. So what I'm going to do is I'm going to keep it as it is. I'm going to make a copy of this entire circuit diagram. It's very easy. Just left click and draw a rectangle to select all the wirings and all the components, and right click, and you get these menus called block copy, block move, block rotate, and block delete. I'm going to use block copy. So you just you know that there's a copy that follows your mouse. I'm going to place it for the time being here, and you can keep on copying and make a number of copies. I'm going to just say escape so that it's gone. Now we'll start working on the diagram in the center. So make it at the center. Now you still need little bit space here to have your current, or what let's try to do with whatever you've got. Now you have to be careful with the leads, the endpoints of the component, which is in the red line, and the green lines are the wires. These current and voltage probes, they have to be placed on the green lines on the wire, not on the red on the component leads. So if you go and click on the left hand side, you got this icon here, that's the probe mode. You can see you got voltage, current, and the tape. So it will be helpful for you to have an earth point. So I'm going to explain why you need an earth point maybe at the end of the video. So what I'll be doing is go to this terminal mode, bring the ground point here, and place the ground point somewhere here. So I got a ground point. So now I'm going to bring the voltage probe. So assume that I want to know the voltage at this point, which you already know. This has to be the 5 volts, because all this wiring which is at the connected to this battery are all at the 5 volts. Where I'm going to place one, you just click on the voltage probe, move the mouse. This icon, you get this pencil icon. That means you're in the drop mode. Again, and as I mentioned before, these type of words like a pencil icon and drop mode you learn by reading this help text. I'm going to place a copy here, and it automatically gets a name. Now this name B4 corresponds to the nearest component for this voltage source, that is the battery 4 here. You can always go and change this name. Say just a double click, and you can change that B4 plus to say B80. So I got that. Okay. Next, I want to measure the current in this branch. Now I'm going to place a current probe on this wire here. So take the current probe. Now place it anywhere on the green wire. Now you get this the current probe, and this arrow, so that should be always in parallel to the wire. Now I will show you now a scenario where if you don't keep this arrow parallel, you will get error message. I'm going to show that soon. So again, as we did before, you can double click and change your so the name. I'm going to call this as the main current I. So click outside, you got this thing. Now you can run the simulation and see everything what you have done so far. Now run it. You can see that if you remember, so you can just go and see what was the current. The main current was 1.13 amps. Now you got, if you see here, the current flowing through resistor the 3 ohm resistor is 1.13. So there's a bit of rounding error here. So we know that this current probe works. So stop the simulation. So bring one more current probe. I'm going to place it over here. Now you need some, if you just place it here, let's try to put it over here and see, there is a bit of a clutter here. Now the best thing to do is probably, let's try to zoom this and see whether that makes any okay. So I think the best option for us here is to extend the wire. So I'm going to do that and back to the video soon. So now I have redrawn the circuit with enough space for us to put these probes. So I'm going to bring one more current probe and place it here. Now if you look at this closely, now look at the direction of the current here. Now if you compare this with the previous one, so you know that the current flows in this direction. So this direction symbol of the probe is parallel or in the same direction as the current. Whereas here we know that the current flows in this direction, whereas here this arrow, this direction arrow, is perpendicular to the line. So if you try to simulate now, I'm going to hit the simulate, you will see you get error message. It says the probe object R7 is ambiguously placed. So to solve this problem, you have to right click. You're going to stop the simulation, right click, and I have to rotate this clockwise to make it in parallel, okay, to this Y, say clockwise. Now you can see that it's working all right. However, we still have this problem of overlapping and reading. So there must be some way around this thing. Now I'm going to simulate. So you can see the current is 0.80, which again it's same as what we saw in this earlier. If you look at that, the current is 0.8 here in this branch. So we got exactly the same reading. So I also want to know what's the voltage. So stop the simulation, put an voltage probe. So I'm going to put a voltage probe here, and I'm going to mirror this using y-axis. So not the other way, Control Z. So mirror on the x-axis, X mirror. You get that? Well, that's not good. Control Z. So rotate this one. So rotate this, say anti-clockwise, and one more anti-clockwise. So this is fine. If you run the simulation now, you can see the voltage is 1.61 at this node, and which is same as what we saw before. I'm going to stop the simulation and I'm going to now put the current probe. So one current probe here, and again you have to make sure this arrow is in the direction of this wire. So right click and say rotate clockwise. It is here, and bring one more voltage source and place it somewhere. So let's stop the simulation probably. So bring the voltage source. I want to place it here. Now this wire, whether you place here, here, it's the same thing, isn't it? So I'm going to run the simulation. So you can see that the values we got here, it's same as what we had in this diagram, and the working one, 0.61. So at least now you know how to use, what's a current probe, what's a voltage probe, and you also know how to place the current and voltage probe. And we also know that if you don't match this arrow of the current probe parallel to the line, you will get an error when you start simulation. And in the next one, I'm going to show you what is the significance of this. So if you remember, I mentioned before, somewhere in the document, in the simulation document, they mentioned you can keep the current and the voltage probe outside the circuit diagram and make a connection just to have a nice reading of the current. So I'm going to do the same thing here now. So I'm going to remove this, right click and say delete, and bring a current source. I'm going to keep it completely above the circuit diagram and connect that here. Make sure this current direction is parallel to this wire. If you run the simulate now, you can see that the current 1.66 amps you can see here. So this is much better than having everything here. However, what I also noticed is if I try to do the same thing to find the current in this branch, you get a different result. I'm going to delete that and place a current probe somewhere here, and drop a wire from there to here. And if you got a simulation error here, and the reason is this arrow does not match the direction of the current in this wire. So right click and say rotate clockwise. Now this arrow is the current direction arrow is in parallel to this wire. If you simulate now, so sorry, it says again there's some problem there, issues. So it looks like you cannot measure the current in the branches using a probe here. So you can try to keep a probe somewhere else. I'm going to keep the probe say here, and drop a wire from there to this point here. And if you simulate, you got this probe error because of this arrow, the current arrow. Make the current arrow here parallel to this wire. Say right click clockwise, and if you simulate now, again, okay, you can see there's some issue here. So at least we know that we can measure the current by keeping the probe outside on a wiring that's horizontal here. So I'm going to show you now what's the reason behind using the ground point in your circuit. So here you can see I have got a 5-volt cell. I'm going to place a resistor, connect a resistor to this battery. So here you got resistor. I'm going to rotate this so that it's vertical and place here, and I'm going to connect this, and I've got connected here. Now I'm going to measure the voltage at these 2 points. Now you know that this is the plus 5 volts and this is the minus 5 volts, and you know that this is the 5 volts here. This point will be 5 volts, and this point will be, we think it's a 0 volts. Now see, this is a 5-volt battery. So you can get 5 volts by having 5 as a positive and 0 as negative, or I can have 2.5 volts on the positive and minus 2.5 volts as a negative. Even then the difference here is 5 volts. Now something like this is happening here as well. So I'm going to bring the voltage probe here. So get the voltage probe, one at this point and the one at this point. Now if I simulate, and you will see what's happening here. Also there's something wrong. It is probably something to do with our earlier circuit. Yeah, it's something to do with this one. Now let's delete this one, delete and delete. Okay, now simulation working all right. Now go back to where we were. Now here, simulate. You can see that the top end shows 2.5 volts and the bottom end shows minus 2.5 volts. There's nothing wrong here. Even with these values, the voltage across the resistor, which is the difference between the resistor, that's 2.5 minus or minus 2.5, that still gives you the 5 volts. But however, we are not comfortable with these negative voltages. So the reason why you get a negative voltage is somewhere in the documentation of simulation documentation, it mentions about the how the earthing, the ground line is determined. It says if the ground wire is not there, if you don't put a ground point there, the middle of the battery is taken as the ground line. So the middle of the battery is, on the top is 2.5 and the bottom is minus 2.5 and the middle is 0. So this is how the simulation takes the voltage if there is no battery. So in order to overcome that, so what you have to do is just go to the node, go to the terminal nodes and bring a ground point. Stop the simulation. So bring the ground point and just connect it here. Now when you simulate, you can see that the top is 5 volts and the bottom is 0 volts. Even with these numbers, the voltage difference between this resistor is still 5 volts. So I hope this video helped you understanding the current and voltage probe and about this ground. Thanks for watching.